Hello guys, you are welcome. In this video, we will treat the topic of reducible polynomials. Before we begin, if you haven't yet subscribed to this channel, please do and turn on your notifications so you get updated on each new video. Now let's begin. A reducible polynomial is a polynomial that can be reduced into products of smaller chunks called factors. Now let's use an analogy with whole numbers without considering the factor number 1. We have two numbers here, number 18 and number 19. And you see that the number 18 can be reduced into three other whole numbers whose product will give you back the number 18. And we know what factors are. Factors are numbers that can divide another number without leaving any remainder. So we will divide 18 to give us 9 without any remainder. 3 we divide 18 to give us 6 without any remainder. And then when we move on to the whole number 19, you agree with me that the number 19 does not have any smaller factors. That's why it is called a prime number. So it's the same thing with polynomials. In this case, the number 18 can be said to be reducible, and the number 19 can be said to be irreducible. So it's the same thing in relating with reducible polynomials. Reducible polynomials are polynomials that can be broken down, reduced into smaller chunks of factors. Now, in order to understand how to work around this concept, we will need to understand remainder theorem and factor theorem. So this is your remainder theorem. I like to say that the remainder theorem is like a coin with two faces. And on the first face, we have when we divide a polynomial f of x by another polynomial of the form x minus a, your a being a constant, the remainder is the value of f of a. And how do we come about a? If our x minus a is equal to 0, that means our x is equal to a. So in your original polynomial f of x, wherever you have x, you substitute a. And whatever your answer is, that is the remainder. And then the second side of the coin says, when we divide a polynomial f of x by another polynomial of the form x plus a, your a being a constant, the remainder is the value of f of minus a. So you have your x plus a equals to 0, and then your x, the solution for your x becomes minus a. So by the time you substitute minus a into f of x, whatever solution you come up with, that is the remainder from dividing that polynomial by the divisor x plus a. See, now we are using terms from division of polynomials. Now let's try out an example to prove this. When x squared minus 5x plus 1 is divided by x minus 2, and secondly x plus 1. We have to find the remainder. First of all, let's do our long division, then we'll apply the remainder theorem. Now for the first one, a, x squared minus 5x plus 1 divide by x minus 2. We do our long division now. X squared divided by x, we have x. X times x, we have x squared. X times minus 2, we have minus 2x. Then you subtract this, you have 0. 5x minus 2x, you will have minus 3x. You bring down your 1 plus 1. So x can divide one more time. Minus 3x divided by x, and we have minus 3. Now minus 3 multiplied the whole divisor, and we have minus 3x plus 6. Then you subtract this, we will have minus 5. This is the remainder. Now let's apply the remainder theorem. We are dividing our f of x being this, by x minus 2. So that means this implies that x minus 2 equals 0, and then x is equals to 2. F of x is equal to x squared minus 5x plus 1. So f of 2 equals to 2 squared minus 5 times 2 plus 1. So this is equal to 4 minus 10 plus 1. 4 minus 10 is minus 6. Minus 6 plus 1 is minus 5. So that means we can find the remainder without having to go through the long division process. Just apply the remainder theorem. Now let's prove again with the second one. B x. This time we shouldn't even do the long division. You can do this long division by yourself, but then to find the remainder, given that our x plus 1, if we equate this to 0, that means our x becomes minus 1. So f of x is equal to x squared minus 5x plus 1. So f of minus x is equals to minus 1 squared minus 5 minus 1 plus 1. So you have 1 minus 1 squared is 1. Minus 5 times minus 1, we have plus 5 plus 1. So we have 7. F of minus 1 is equal to 0, 7. What this means is that if you divide, by the time you do your long division, you will have a remainder of 7. So that is that on remainder theorem. Now let's move on to factor theorem. This is what factor theorem states. It states that given f of x, and it's just like I said, the remainder theorem is it's like a coin with two sides. The same applies with factor theorem. So it says, if the first phase says, if f of a is equal to 0, it means that x minus a is a factor of f of x. That means x minus a will divide f of x without leaving a remainder. And secondly, if f of minus a is equal to 0, then x plus a is a factor of f of x, meaning x plus a will divide f of x without leaving any remainder. Now let's try out an example to prove this. So in this example, we are given a polynomial as seen there, and we're told that it's divided in turn by 3 different divisors, x plus 1, x minus 1, and x minus 2. We are asked to find the remainders, and what can we deduce from finding the remainders. So given this f of x, and first of all, we're told to find the remainder when divided by x plus 1. So what we'll do now, we'll find the solution for x, which is x plus 1 equals 0. So therefore x is equal to minus 1. So our f of minus 1 equals to minus 1 cubed minus 2 minus 1 all squared minus 1 plus 2. Simplify this, and this becomes minus 1 raised to the power 3 is minus 1. Minus 1 raised to the power 2 is 1. So 1 times 2, we have minus 2. Then minus 1 we have plus 1. Then plus 2. By the time you simplify this, minus 1 minus 2 is equal to minus 3. Minus 3 plus 1 is equal to minus 2. Minus 2 plus 2 is equal to 0. So that means x plus 1 is a factor of f of x. That means if we do our long division, x plus 1 will divide f of x completely without leaving a remainder. Bring those to x minus 1 divided by x minus 1. So our x minus 1 equal to 0, such that x is equal to 1. So by the time we have f of 1, we have 1 raised to the power 3 minus 2, 1 squared minus 1 plus 2. So this becomes 1 minus 2 minus 1 plus 2. 1 minus 2 is equal to minus 1. Minus 1 minus 1 is equal to minus 2. Minus 2 plus 2 is equal to 0. So therefore x minus 1 is a factor of f of x. So that means x minus 1 will divide through f of x completely without leaving a remainder. You can test this with your long division, and then you can try also do the same test with your x minus 2. What you'll find is x minus 2 is also a factor of f of x. Now let's move on to an example from the manual. So in the manual, we have two examples under reducible polynomials. So we're going to walk through each of them step by step. In the first example, we are asked to factorize the polynomial given there. And in saying factorize, we can also say reduce. So we'll just go into it. The polynomial is this. F of x equal to x raised to the power 4 plus x raised to the power 3 minus 5x squared plus 3x. So we'll do a trial and error that is testing different factors. Let's try x minus 1. X minus 1 will imply that x is equal to 1. So let's do f of 1. F of 1 is equal to 1 raised to the power 4 plus 1 raised to the power 3 minus 5 times 1 raised to the power 2 plus 3 times 1. This is equal to 1 plus 1 minus 5 plus 3. 1 plus 1 is 2. 2 minus 5 is minus 3. Minus 3 plus 3 is equal to 0. So that means that x minus 1 is a factor. So now that we've found at least one factor, instead of doing trial and error again, we can find the other factors simply by dividing the polynomial f of x by a newly discovered factor, x minus 1. So we do this x minus 1 and f of x divided by x minus 1. So x raised to the power 4 divided by x, we have x cubed. X cubed times x, we have x raised to the power 4. X cubed times minus 1, we have minus x cubed. Then you subtract this, x minus 4 minus x is 0. Then x cubed minus x cubed is equal to 2x cubed. We bring down the other members. So 2x cubed divided by x, and we have plus 2x squared. Then multiply the divisor by 2x squared. You have 2x cubed minus 2x squared. Subtract this. This is 0. Minus 5x squared minus 2x squared will give us minus 3x squared plus 3x. So minus 3x squared divided by x will give us minus 3x. Minus 3x multiplying the divisor will give us minus 3x squared. Minus 3x times minus 1 gives us plus 3x. By the time you subtract this, you have 0. So that implies that our f of x is equal to the product of x minus 1 and x cubed plus 2x squared minus 3x. So we can further factorize this factor. That is, we factor out x. One thing that is common between all three terms is x. So we can factor it out. This becomes x minus 1, x, bring out x here, you have x squared plus 2x minus 3. So this can be factorized further. This is your this is a quadratic expression. And how do we factorize a quadratic equation? We find two numbers that will be added to give us plus 2, and that will be multiplied to give us minus 3. In this case, that will be 3 and minus 1. 3 plus minus 1 is equal to 2, and then 3 times minus 1 is equal to minus 3. So we do this, x minus 1, then x squared plus 3x minus x minus 3. So let's just single this out and factorize it. This becomes x squared plus 3x minus x minus 3. What do we have in common here? We have x, we factor out x, and you have x plus 3. What do we have in common here? Minus 1. This becomes x plus 3. So that means this is equal to x minus 1 and x plus 3. So the final answer is x minus 1, x minus 1, x plus 3. So you see that this polynomial here has been reduced into 4 smaller chunks. So in the second example, we are given a factor, which is x plus 1. And then we are given f of x, which is equal to 2. F of x is equal to 2x raised to the power 4 plus 2x cubed plus ax squared minus 3x plus 2. And the instruction is to find the value of a if x plus 1 is a factor. So what we just do here is that we'll apply a factor theorem. If x plus 1 is a factor, then x is equal to minus 1. So we substitute minus 1 into f of x. And we have, and if x is a factor, that means f of minus 1 is equal to 0. So we substitute 1 into f of x and equate it to 0. So we have 2 minus 1 raised to the power 4 plus 2 minus 1 raised to the power 3 plus a minus 1 all squared minus 3 minus 1 plus 2 equal to 0. Now, minus 1 raised to the power 4 is 1. 1 times 2, we have 2. Minus 1 raised to the power 3 is minus 1 times 2, we have minus 2. Minus 1 raised to the power of 2 is 1 times a, we have a. Then minus 3 times minus 1 is plus 3 plus 2 equal to 0. So by the time we simplify this, 2 minus 2 is 0. 3 plus 2 is 5. We have a plus 5 equal to 0. So therefore, our a is equal to minus 5. That's our final answer. It's that simple. So here's an exercise for you to attempt yourself. Let me know how it goes in the comments, and also reach out if you need further guidance. Please remember to like this video and share it with others if you found it helpful. Thank you.